Hello boys and girls, welcome back to Extreme IE. In this video we are going to talk about containers. Specifically, we're just going to talk about what containers really are, right? What's the definition of a container? What does a container do, and why would we use it? So down here you'll see that I have a link to docker.com. You can follow that link and you can go to their webpage and you can read the full 2-page article on what they define a container to be. I've pasted in here just the first sentence or two of what they define a container is. So let's just read it together. A container is a standard unit of software that packages up all of the code and all of its dependencies so the application runs quietly, reliably from one computing environment to another. So what does that mean exactly? Well, let's talk about your typical server deployment, right? Let's say that we were going to deploy WordPress. What would that look like today in a virtualized environment? So first thing we would have is our hardware. So obviously we'd have a Dell server, HP server, IBM, doesn't matter. You'd have hardware of some kind. And then assuming we're running VMware, on top of that, we're going to have our virtualized layer, right? This is where we're going to actually install our ESXi operating system. Now, depending on if you're running VMware or maybe something like Hyper-V, this may change because obviously on top of the hardware, you're going to install the Microsoft operating system and then Hyper-V on top of that. But again, we're just going to go with VMware here to keep things a little simple so you understand the architecture here. And by the way, keep in mind that I am left-handed, so if things gravitate this way, I apologize. And then the next thing we're going to do is we're going to run the operating system on top of that. Now, this operating system is going to be typically, Windows or Linux, right? So we'll just say Win or Linux, either one. We'll go with Linux for now, right? So we'll just say here, we're going to Linux. Whoops. We're going to say Linux. That's an X. All right, so we're going to say that we're going to run Linux for now. And then on top of this operating system, this is where you're going to run your different software dependencies. Now, again, we're shooting for WordPress here, right? So on top of, inside of this software bucket, on top of the operating system, we're going to run things like Apache. We're going to install things like MariaDB. And the reason why we're doing this is because in order to get to our application layer, in order to actually build our application, which again is going to be WordPress, so we're going to say WordPress, we need these various different dependencies. And so all of this together is going to constitute our single machine. Now keep in mind that right here is essentially your VM, right? This is your virtual machine, essentially from this layer up, right? Now let's just say that we want to clone this times 3. We're going to have to actually build this operating system and all of these packages 3 times, regardless whether you go with a template or you clone it. It doesn't matter what you do. Regardless, you're going to have to build this 3 times. And each VM is going to require its own CPU resource, its own memory resource. It's going to require its own hard disk resource. It's going to require all of these resources times 3, right? And don't get me wrong, this deployment is a standard deployment that we run today, and it's awesome. This actually opened the floodgates to scalability. Why? Because instead of having to go and replicate this hardware server times 3, this architecture enabled us to scale this out. So we could go and we could build, we could buy a pretty hefty hardware box, and we could install this once, we could install this once, and then essentially we could have 3,000 VMs living in just this architecture as we scale out. So this is an amazing architecture, don't get me wrong, right? But even in this model, we typically have that one virtual machine doing this one application. So even though we've scaled out this way, we used to have one server doing one thing, now we have one VM doing one thing, right? So again, even in this model, we have some limitations, and each VM again requires its own CPU, its own memory, it requires its own patching, it requires its own updates, it requires all of these different things per VM that we run. Also think about, again, these software dependencies, right? So I have to essentially install these dependencies 3 times, and each one of these dependencies requires their own patches and their own updates, etc., right? So I'm essentially doing these patches multiple times possibly. And so the question becomes, how do we deploy our application in such a way that we always have their required dependencies, so we always have these things, right? And at the same time enable us to save even more resources, right? Because again, the introduction of VMware allowed us to save resources here. But how do we now save resources here. And at the same time, again, saving resources, meaning CPU, RAM, etc. And at the same time, giving us the ability to actually speed up performance. So instead of this maybe taking 5 minutes to boot up, and when I say 5 minutes, I mean the actual application itself, this part we're not going to be able to change. So if this takes 3 minutes to boot and actually get to the point where our VM and operating system start, this total may take us 9 minutes, right? How do we minimize this to maybe 4 minutes? Can we do that? Can we come up with a way to limit or minimize the amount of time this all takes to boot up? That is what a container does. All of these things that I'm talking about, this is what a container is meant to do. A container is the answer to this problem. A container is a self-contained unit of software, okay? It's a self-contained VM, if you will, if you want to think about it that way. It's a self-contained VM with all of those standard dependencies, all of the code of your application, everything it needs to successfully run, while enabling us to move this machine back and forth between environments. So I might be able to take this container that's running, on my dev machine, on my dev cluster, on my laptop possibly, and move it into a production environment with no problem, right? This is the whole idea. And we achieve this by actually sharing, let me pick a different color here because things might get confusing. Hope purple stands out good. By sharing the operating system kernel. And if the purple doesn't stand out there, I apologize. But we do this by sharing the operating system kernel right here. Let me pick a different one actually. Let's try maybe blue. Maybe that might be a little bit better. Okay, so we share the operating system kernel across all of the different containers. So imagine this, you build this machine, you install the OS on your VM, and then you can replicate this OS as many times as you need to per the containers that you're going to run. This essentially allows us to essentially replicate everything that we need into a container. Okay, and this is the reason why back in the day we couldn't move a container from, let's say, Windows to Linux and back and forth. We couldn't do that back in the day. But in today's day and age, with the introduction of WSL and Docker, which we'll get to in just a second, Docker for Windows, this is becoming easier. So again, at the time you watch this video, this may not be possible, but in a year from now, this may be possible. So don't just marry and say, oh, I can't move from Windows to Linux or from Linux to Windows. Again, the time you watch this video, that might be possible because things are changing all of the time. People develop a container in Windows and maybe they want to move it to Linux. So let's take a look at this architecture, the same exact architecture in a containerized environment. So you're still going to have this hardware platform. You're still going to have your virtual platform. You're still going to have where you build your OS. Again, this is your VM. This is your ESXi server. And then this is, we'll just say it's Dell, right? Or UCS. At this point, you're still going to go and you're still going to install all of your software dependencies like Apache, like MariaDB. But in addition to that, what you're going to install is your container. I'm going to say engine /runtime, RT, right? Now, these terms can be used interchangeably, and here's really why I put container, engine, and runtime. So the engine, okay, the container engine, this would be equivalent to kind of like ESXi is to VMware. So this is the actual container management. This is the actual container operating system, if you will, that allows us to actually run the container. And there's many different kinds. There's containerd. I'm just going to put a few here because in case you've heard these names, you know what I'm talking about. There's Docker. There is Cryo. I call it Cryo. So there are multiple different kinds of container engines. Now the runtime is what's actually going to communicate to the operating system and allow us to mount and run the container. So this runtime is actually part of the engine. It's a component of the container engine. So if I say container runtime is Docker, what I'm saying is that the container engine is Docker, and obviously the runtime is just a part of that. Okay, so I just want to make sure that we're clear there. So in addition to all those software dependencies, I'm going to install this container engine. And then what I'm going to do is, instead of installing my WordPress here, right, instead of installing it directly above the software where I normally would, I'm going to go ahead and I'm going to build a container. And that container is where my WordPress is going to live. And in addition to the WordPress actual app container, I'm going to have all of my libraries and binaries that come or that are required to run this application, and those are going to come from the kernel operating system as well as my software dependencies. And as I need more containers, I'm just going to go ahead and replicate those and deploy as many containers as I want to, and each container is going to come self-packaged with everything that I need in order to run that container. So rather than installing it multiple times, rather than maintaining multiple versions of this operating system where, okay, you know, VM1 is at one patch level and VM2 is at another patch level and VM3 doesn't have any patches at all of my containers are coming from this root operating system and this root library of software. And these containers can be identical. And then what I can do is, if I'm using something like Kubernetes or OpenShift, which is essentially, that would be considered like vCenter for VMware, we'll just say vCenter equals Kubernetes, right? What I can do is I can then build, just like you would build a cluster in vCenter, you can build a cluster of containers, and you can have these living on different software servers, right? Different VMs, if you will. We call those worker nodes, but we'll get to that later. So this is how a container environment, it actually makes things a lot easier when it comes from a management perspective. And large organizations like Google, Apple, Facebook, they've been using containers for years because of this exact reason, because it enables them to manage things much easier. It enables them to keep track of things much easier. It saves on resources. It saves on how much money you need to throw at these things. It really is a better consumption model for, I should say, the evolution of our virtual environments. So I hope you guys enjoyed this video. I will see you guys in the next one.